blending, lubrication. These are the processes used in the pharmaceutical industry for making the different formulations like tablets, capsules, granules, directly compressible blends, and material for filling the sachets. This video is for the critical process parameters, critical material attributes, and critical quality attributes for the blending and lubrication process. Let's start with the video with the introduction of blending and lubrication process. Generally, we can say that blending is the unit operation in the pharmaceutical industry which is used to mix the materials to make the uniform mixture or blend of the dry powders, or you can say that the blending is the process of mixing granules together along with some extragranular materials and lubricants. It is also called as dry mixing process for making the formulations like tablets and capsules. Also for making the powders like ORS, filling the sachets with granules and powders, and also sometimes mixing of the pellets. Critical process parameters for blending and lubrication are percent occupancy or fill level of the blender. So the fill level should be optimum so that mixing will be proper. Generally, the fill level of 40 to 60% is the optimum level, and it depends on to the blender qualification range. Then order of material loading, addition, or you can say layering and sandwich addition. So how the materials are loaded, which material is loaded first, which material is loaded after. So that is the order of material loading or order of material addition in the blender. So layering or sandwich blending affects the blending process. That's why the percent occupancy fill level and order of material loading is the critical process parameter. Then another one is the blending speed and time. So as we understand, percent occupancy fill level and order of material loading is the procedures or is the process which we can control, and it is the process parameter. But the main process parameter is the blending speed and blending time. We can also say that the number of revolutions or total number of revolutions is the most important critical process parameter for blending and lubrication. Then the intensifier bar, whether it is used or not, whether it is on off with some pattern, so that also affects the blending process. Blending process outcome is uniform mixture of the materials and uniform distribution of the API in the blend. So these are some of the critical process parameters for blending and lubrication and dry mixing process. Mainly the critical process parameter is blending speed and time, and you can calculate number of revolutions as per blending speed and time. So the blenders which are lower in volume or in size, like 2-liter blender, 5-liter blender, 10-liter blender, these are the small scale lab equipments, while 100-liter, 200-liter and above these occupancies or capacities, these are the production scale blenders. Generally, the smaller size or capacity blenders are rotated at higher speed compared to the larger capacity blenders to match the tip speed. So that we will cover in separate video in scale up factor. For this video, remember regarding the blending speed and the blending time, which will give you the total number of revolutions. Now coming to the critical material attributes. So what are the material attributes which affects the blending and lubrication process or dry mixing process? These are related to the materials which are required to be blended together. These are API and excipients generally. Sometimes only excipients are also blended. So density of the materials which are getting mixed and the density differences among these excipients. If you are mixing a high density material with lowest density material, then it will be very difficult to mix it uniformly and it will segregate. So density and density differences. Another critical material attribute, that is CMA, is flow. How is the flow of the material? Then particle size differences, static charges, cohesive and adhesive nature. If material are too much fine, for example, some APIs are too much fine in nature, these APIs have static charges and these static charges may lead to formation of lumps and may not mix properly. Cohesive and adhesive nature of the material has a great impact onto the blending and lubrication process. API load in the blend. So how much API percent content is present in the blend, how much API is to be mixed. If it is very low, then it is difficult to mix it properly. If it is optimum, then it will be easy to mix. API and excipients ratio. So it is the same thing, like how much API and how much excipients are required to be mixed. Then glidants and lubricants level. What type of excipient is being added in the blend to promote the flow and to increase the blending efficiency. Glidants and lubricants improves the flow of the material and thereby lubricants and glidants helps to mix the blend properly. So always it is included in the blending process. The different glidants and lubricants are like colloidal silicon dioxide, talcum or talc and magnesium stearate. Others are also used. So these are the critical material attributes for blending and lubrication. Now coming to the critical quality attributes. So together critical material attributes and critical process parameters affect the sequence of blending process. Sequences are blend bulk density and tap density, blend flow, blend assay and uniformity. These are the most important critical attributes. First is density, flow, blend assay and blend uniformity. The impact of the CMAs and CPPs is evaluated through blend assay and blend uniformity. Now, this sequence of the blend will affect the sequence of the formulation. Whether you are using the blend to compress the tablets or fill the capsules or fill the sachets, based on the formulation, the physical and chemical sequence will vary. For example, tablet hardness impact will be there, weight variation impact will be there, sticking picking nature will be impacted through the blending and lubrication process. If the lubricants are ineffective or lubrication process is not proper, it may lead to sticking and picking in the tablet manufacturing, weight variation in tablet manufacturing and capsule filling, tablet hardness variation. So these are related to the blending process sequence. Then assay and content uniformity will be impacted. If the flow is not proper for the blend, it will have impact onto the tablet weight variation, and thereby it will impact assay and content uniformity. Then if the lubrication is over, that means over lubrication will make the blend hydrophobic and it will have impact onto the dissolution of tablets and capsules. So always understand regarding the blending process, lubrication process or dry mixing process, CQAs impact onto the finished product CQAs. So together CPPs, CMAs and CQAs of the blending and lubrication process will impact final physical and chemical CQAs of the tablets, capsules and the sachets based on to the formulation which we are going to manufacture. So I hope you have good idea about this topic from the video, and let's meet you soon with such kind of informative video. I will like to answer your queries. So if you have any questions, please write it into the comments. Thank you.